Let's start off with the first unit of DSci 2000. With every set of slides, I will include an objectives slide outlining the goals of each lecture. Please pause and read this slide before proceeding. To begin the class, from your perspective, you've enrolled in this class called Introduction to Data Science. I imagine most of you are wondering what data science is. Let's begin by addressing this question. What is data science? Well, from my perspective, if you were to ask people that question, you would get one of two responses. They either have no idea or they would not have the same opinion of what constitutes data science. Why is this? Well, some data scientist positions are just former data analyst, statistician, and similar positions just retitled. One of the most frequent questions I get from people in general when I tell them I teach data science is, what is the difference between a data analyst and a data scientist? My response to them is that there is no point trying to make that distinction because there is no legal or credential distinction between those titles. For example, in accounting, you have CPAs. CPAs must meet certain educational and examination requirements to be considered accountants. As another example, to be considered a medical doctor, you have to meet certain educational and examination requirements. There is a concrete difference between, say, an RN and an MD. There is no similarly established difference between data analyst and data scientist, and trying to say that such a difference exists in the current environment would only lead to intense debate. On top of some data science positions being just retitlings of prior positions, skill sets are inconsistent among data scientists. I've met data scientists who tell me that they don't program and do all of their work in Excel, and I've met data scientists who do a ton of programming. I've seen data science positions that were actually more like web development positions, and I've seen data science positions that require you to know the mathematical foundations of machine learning. On top of this, there are also data science positions that don't care how much math you know and just want you to be able to code. Degree requirements are also inconsistent as well. Some data science positions will happily accept applicants with a bachelor's degree. The majority of positions I've seen require at least a master's degree, and there are some research-intensive roles that require a PhD. To say the least, in my opinion, trying to define what data science is cannot be done in the current environment and isn't something I'm going to try to pursue in this class. One factor explaining these inconsistencies are the people who hire these data professionals. Most people do not have formal training in data analysis, machine learning, statistics, or math at the level necessary for professional work. Thus, as you might guess, most managers usually don't have the technical background to understand what it is they need with respect to data. Many of these people are hoping to just hop on the AI bandwagon because they think AI will give them good results and insight. One very popular visualization for describing data science is this Venn diagram by Drew Conway. This visual can be summarized in 3 pieces: hacking or programming skills, math and stats knowledge, and expertise in a subject of the domain of interest, such as healthcare when you're working with healthcare data. However, if we wanted to bring this model to a broader audience, there are a few things to keep in mind. First of all, most managers don't know what math and stats are at the level a data professional would need it. Second of all, as I mentioned already, not all data science positions require programming. But I think, keeping all of what I've mentioned already in mind, we could summarize data science as follows. It is the act of taking data and delivering insight to stakeholders. A completely valid question is, given the prior definition, what's the difference between data science and statistics? Well, if you were to ask most statisticians, they'd tell you that there is no difference between the two. From my perspective, though, there's much more of a focus on wide data as well as more of a focus on computational efficiency in data science than there is in statistics. Computational efficiency issues are not traditionally of focus in statistics. Again, this is just my opinion, and the answer you will get to this question will depend on whom you ask. From my perspective as well, data science is running into problems with its users who run all these sophisticated methods, but don't have the background to understand what drives these methods. The impression I get from people hiring data scientists these days is they don't want someone who can just run code to execute a method. They also want candidates who know the underlying theory. Statistics could really contribute a lot to helping with this. I'll elaborate on a future set of slides. Throughout this class, I'm going to refer to what I call the 2 levels of data science. Please know that these are not standard terms in industry, and there are exceptions to what I have here. I'm only using these terms for this class so that it's easier to communicate my intent. A level 1 data science position is one in which you're expected to do traditional operational reporting with basic summary statistics, such as averages, with a programming language. These types of positions usually, but not always, have job titles such as business intelligence analyst or data analyst. A level 2 data science position has all of the required skill set of a level 1 position, except it requires more of a mathematical and statistical background. The fundamental skill set I would consider for this position would be around graduate level statistics and having an undergraduate level command of computer science. Level 2 positions have some expectation that you can optimize your code using something like C, C++, or Java. They also expect you to have command of linear algebra and how linear algebra applies to probability, statistics, and machine learning. Typical job titles for a level 2 position tend to be, but are not always, decision scientist, data scientist, and machine learning researcher. DSci 2000 is meant to prepare you for a level 1 position. You will need more math beyond DSci 2000 to obtain the background for a level 2 position. I want to make this clear. If you intend on becoming a data scientist, you will probably not be able to do it with just a bachelor's degree. As I mentioned, a graduate level command of core statistical concepts is usually expected. I would bet that if you were to search on a job postings website for data scientists, most would expect you to have at least a master's degree. Students have asked me on occasion if they can become a data scientist after taking DSci 2000. My answer to these people has always been that this course will teach you the foundational material, but you need to know even more beyond DSci 2000 to prepare yourself for that type of work, especially in math, stats, and CS. Another thing I'll mention for now, but will elaborate on later, is that academic programs tend to treat level 1 work as an afterthought and focus on level 2 work. From my perspective, this is a missed opportunity. Many organizations are at the point right now where they need to develop fundamental things like data infrastructure, and they're not ready for sophisticated things like machine learning. Keep this in mind should you pursue further study into data analytics. Here are some phrases that you may run into that are synonymous with data science. These include artificial intelligence, business intelligence, data analysis or analytics, decision science, machine learning or deep learning, predictive modeling, and statistical modeling. For the most part, people agree that machine learning is part of a broader field called artificial intelligence. Deep learning, although most people would probably not know what it is the name of a specific machine learning technique. People also generally agree that data scientists use machine learning, but data science is by no means machine learning. But the one thing I really want to leave you with in this lecture is this: data science is not magic. It doesn't matter what buzzword you use to refer to data science. Whether you call it AI, machine learning, etc., these things are not magic. They are essentially complicated functions in both the CS and the mathematical sense. Recall that a function in both CS and math takes an input and spits out an output. The input is the data that you have available at your disposal as a data professional to spit out an output. So this means the following. If you have terrible input, i.e. poor quality data, you will get bad output out of your function, no matter what buzzword you attach to what you're doing, and no matter how sophisticated your techniques are. This is the reason why so much time as a data professional is spent on cleansing data. Here's an XKCD on machine learning in case you'd like to view it yourself. As we're finishing this lecture, I imagine you're left with more questions than answers. I want you to know that this is to be expected and not to be concerned if you feel that way. When I gave this lecture for the first time to an in-person group of students, I had a ton of questions that were asked, and by my impression, my answers were not very satisfying. The intent of this lecture at the beginning of DSci 2000 is to illustrate to you how complex data science is, and you need to be aware of its complexities as soon as possible. Unlike, say, mathematics or computer science, data science has not had at least a few centuries or decades to mature as a field. Thus, this uncertainty comes with the territory. But remember that you're not alone in any of this. Please be sure to ask me for help through email and Discord as you have questions, and I'll be happy to answer them.